The screen is visible?
Yes, sir.
Yes, sir.
Okay, thank you very much. Okay, if you remember in the last class, we did this part that is basic elements of a mechatronic system. So we have seen that basic elements, they revolve around the mechanical system. So for sensing any data from the mechanical system, we use digital or analog actuators. And with the data is then processed in a microprocessor to see whether the input or the output coming from the mechanical system is up to the mark or not. Okay, so if the output is not up to the mark, that needs to be sensed, and again an input needs to be given to the actuator so that it can make the required changes in the mechanical system. This could be a movement which needs to be there, or this could be running of any links that is required. Okay, so this type of complete system would be comprising of the mechatronic system. So basic element, mechanical system having digital or analog sensors for sensing the output, and that output they will then be converted into digital form. So microprocessor will always have an input in the form of a digital signal. So you need to convert it from analog to digital signal. So there we require the analog to digital converter. So now after processing, the microprocessor is giving some output. Okay, and that means here we need to again convert the digital form into analog form. So the output of a microprocessor will again be a digital output. Then we will utilize a digital to analog converter over here, which will then run the actuator, and your mechanical system will be compensated accordingly. Okay, so this was the part we did in the last class. So moving further, we have just a second. Yeah. Now the mechatronic system, type of mechatronic system. So this is which we were going to start. So if you have done it already, we will just do it very quickly. Okay.
Excuse me, sir.
Yes.
Sir, background voice आ रही sir काफी.
बैकग्राउंड आवाज मेरी यहाँ पे तो नहीं आ रही, कोई आपके डिस्टरबेंस वैसे ना हो कहीं पे. सो यहाँ पे तो बिल्कुल साइलेंट है. किसको आ रही थी बैकग्राउंड? राजन आपको? हेलो.
ये सर वो एरर आ गया था Zoom पे. ठीक है.
अब ठीक है? Okay. So I hope everyone else is having a clear voice. You are hearing clear voice, or is there any disturbance going on?
Clear है.
Okay.
Sir, clear voice.
Okay, okay. Thank you very much. Thank you. So now the mechatronic system. So we will start with the type of mechatronic system, and we will just quickly finish it. And we will mostly be concentrating on the systems which will be required in this particular subject. Okay. And from mechanical point of view, we will try to focus more. So if we talk of mechatronic system, so there is always you can say requirement or easiness of working with the mechatronic system if we are able to convert it into a block diagram or a model type of system. Okay, so whatever mechatronic system you want to design, if you convert it first to a block diagram or a model system, then you can work very easily on that system, because you can divide the mechanical systems as well as the electronic systems, and the actuators, sensors, all those can be divided into number of blocks. So it becomes very easy to work on to those systems. Okay. Moreover, when you are simulating also these type of systems, when you are simulating it in the software, some software, they are also working on the models or the block diagram type of figures is much easier to understand also and to implement also, as compared to the system which is a little more complicated, or which is having an integrated system to one another. There, its division into blocks is much recommended, and it makes the system very easy to understand. Okay. So if we talk of now, once we have converted it into a block diagram, from there we can learn that the mechatronic system can be further divided into number of systems, starting with the simple system. A simple system, we will just see the definition, which has an input and an output, and where we are concerned not with what goes inside the box. What is going inside, we are not concerned with it. We are just concerned with what is the type of input and what is the output which we are getting. Okay, so the box, it just gives the relationship between the input and output. So an input is there, some relationship between inside the box, and some output you are getting. So you can make any complicated system a very simple system if you just concentrate on the input and the output, and in between whatever goes on, it can be considered as a single unit or a single box. So all of this will become a very simple unit or a simple system. So it is very recommended or very good to convert the whole system into a simple system, where you will only concentrate between the input and the output and the relationship between input and output. And that relationship will be given by the central unit, which will overall comprise of a simple system. Okay. So three different examples of a simple system where the input and output are connected to each other through different modes, or you can say through different systems. The relationship could be very much different in each case, but they will look alike. Okay. As you can see, all of these look alike, but inside the system, it may be very different systems which are going on. So if we talk of the first system, an input is getting converted into output, and in between we have a spring. So if you want to convert some force, you want to exert some force, and you want some another part to be extended or compressed by a given amount of force, there you will utilize a spring. So spring basically is converting your force into some extension or retraction. So if such type of mechanism is required, there you will utilize a spring system. So it is a completely mechanical system which is converting the force into some extension. Similarly, if you have electric power and you want to convert it into mechanical rotation or mechanical energy, there you can simply utilize a motor. So this is another type of a simple system. Another is if you have a temperature which you can sense, but you want to show the temperature with a given reading on a particular scale, where somebody is able to understand and compare it with the standard scale, there we will use a thermometer. Okay. So thermometer, another type of thermomechanical system where the temperature is sensed and it is converted into some useful form so that somebody is able to understand the output. Otherwise, you cannot just sense and give the rating of the temperature as such. You require some intermediate unit which could convert that non-useful form into a useful form. Okay. Okay, so three different examples showing three different simple systems where some input is getting converted into some useful output for further analysis. Okay. So in between we have those converters or those units or boxes which are able to make some relationship between output and input are comprises of the simple system. Now, according to these relationship between output and input, we have three systems: modeling system, measurement system, and connected system. Now, in a simple system, what is the how the relationship goes between an input and output? So accordingly, we have divided, or the simple systems can be divided into three parts. Okay, so this division is based on the relation type of relationship present between input and output. Okay, so according to the type of relationship, we have three further bifurcations of a simple system, that is a modeling system, a measurement system, and a connected system. So let us now see what are all these systems. So starting with the modeling system. So what is a modeling system? Simple, in simple words, we can say a modeling system is the one which is having a mathematical relationship between input and output. If we have a direct mathematical relationship between input and output, we can have, we will call it a modeling system. So model. So here the modeling is not related to some geometric model, but it is related to a mathematical model. So if you have any direct relationship between input and output, that then it will be called a, it would be called a modeling system. Okay. Examples are force is equal to K times X. That means a constant, and this is the spring constant, and the X denotes the displacement or the extension occurring in the X direction. Okay. So this is a simple relationship which shows force, how force is directly, as we know, force, जितनी आप ज्यादा फोर्स लगाओगे उतनी ज्यादा आपकी एक्सटेंशन होगी या रिट्रैक्शन होगी, जिस भी डायरेक्शन में बात करें, in whatever direction we are talking of. So force will be directly proportional to X, and when we'll remove this proportionality, we need to add some constant to it. So that is a constant, spring constant. So spring constant basically means the stiffness of the spring, that how much force, minimum force should be applied so that spring is able to move to a minimum distance. So वो अपनी stand जो equilibrium position से है, position से कितनी minimum force से वो वहां से हिलेगा. Okay, that is called the spring constant or stiffness of the spring. Okay, the more the stiffness, the more the value of force which will be required for the distance X. Okay, the less the value of K, the less amount of force would be required to move a distance X. So it's like that. Okay, so force is equal to K times X. Now we have seen that there is no time constant in this relationship. There is no time constant, or time is not there. Okay, but every system or a modeling system is influenced by time, because whenever some force is applied to the spring or any system which you take, whatever system you take, consider the mathematical relationship which we have considered here, or if we consider any other mathematical relation also, that relation is basically applicable to steady state conditions when the system has become steady state. But before achieving those steady state conditions, there is always a unsteady state which is going on. Like in this example, you can say, if you are giving some force to the spring, some extension is occurring. Okay, but that extension will only becomes stable after a given time. That means when you suddenly apply the extension, the more amount of forces has to be applied for starting the extension. Then this force will reduce, then it will become stable for, and at this time only you will be able to achieve this extension X. Okay, that means when you start, you go for more force, then you reduce the force and you make it stable. This is almost similar to the stress strain curve which you study in strength of material subject. Okay, so initial stress is always, or force is always high to give that deformation. So this is also deformation X. So on. Similarly, when you are, suppose, heating the water in a kettle, this is another example. You are heating the water in a kettle. Here what is happening, you are providing electricity and the temperature of the water will rise. Here what will happen, that you want to reach the temperature 100 degrees Celsius, but for that, if you are applying a stable electricity also, it will require some time, like 2 minutes, to reach to 100 degrees Celsius from 20 degrees Celsius. Okay, so there may be a relationship between the electricity and temperature, direct relationship इसमें होता है always, but there we don't consider time. But for a mathematical relation to actually attain a steady state condition, there is always some time delay while reaching to that relationship. तो इस relationship पे पहुंचने के लिए आपको कुछ time delay चाहिए. So there is always a time delay. Okay. So clear till this point? Is it clear?
Yes, sir.
Yes, sir.
Okay. Balraj, why have you joined so late? What was the problem? Yes, Balraj, can you hear me? Balraj, are you there? Kindly reply. Okay. Okay, next comes the measurement system. Okay, so measurement system basically comprise of a measurement device. Okay, so there may be not, there could be a mathematical relationship between the input and output, but in most of the cases there is not a single mathematical relation, or you can say there is not a stable mathematical relationship between the input and the output. So it may change with the conditions. So we don't consider it under the modeling system. We consider it under the measurement system. So measurement system की क्या definition होगी? Measurement system is the one which gives some output as a measurement of some input data. Okay. Example is a digital thermometer. Okay, so measurement system is which gives some measurement value of the output. So wherever you are having a measurement value, either in the form of a length, either in the form of a weight, either in the form of time period also, there you will call it a measurement system. At the input level, there may be other type of input which is occurring, but at the output you will get a measurement of any length, any weight, any value in the numeric form. So that will be considered as a measurement system. So very good example is a digital thermometer where the temperature is sensed and the temperature is, the output of the temperature is provided in the form of a measurement scale, which is compared to a standard measurement scale. Okay. So there are three basic elements of a measurement system. A sensor is there, a signal conditioner is there, and a display system is there. Okay. So just considering the example of this digital thermometer, what is the sensor which will sense the signal, which will sense the input signal? And this may be a thermocouple or a temperature sensor. Infrared temperature sensor could also be there. A thermocouple could be there, which will actually sense the temperature. Okay. Here the output will be in the form of an EMF value. So a sensor will have an integrated system in itself. So a sensor का अपना भी एक input और output होगा. Sensor will have its own independent input and output. So overall measurement system का एक input और output होगा. एक sensor का अपना input और output होगा. So sensor always works like this. So thermocouple जो होगा, it will sense the temperature and give some EMF, change in EMF. Okay. Now that change in EMF may not be suitable directly for giving an output in the digital thermometer. तो आपको जो डिजिटल सिस्टम में LCD लगी हुई है आपकी, या कोई आपका मर्करी का स्केल है, उसमें मेजरमेंट देने के लिए जो आपकी आउटपुट है, that may not be sufficient. Now in this case we are talking of digital thermometer, so there will definitely be a display system. So display system जो होगा, that will comprise of a LCD or a LED system. Okay. So suppose the output which you are getting as an EMF from the sensor is not sufficient to produce the display on the LED. तो उसको जितनी voltage चाहिए है display के लिए, suppose it is not that much. So what will we do? We will increase the voltage by some source like an amplifier. Okay. That is called a signal conditioning. That is called signal conditioning. That means you have to condition or you have to modify the signal so that you are able to get the proper output as per the desirability of your display system. ठीक है. तो EMF से हमें ये पता लग गया कितना टेम्परेचर है, तो उसे आपकी एक EMF वैल्यू जनरेट हो गई अकॉर्डिंगली. बट कई बार वो EMF ज्यादा भी हो सकती है, कई बार कम भी हो सकती है, so that it may not match with the requirements of the display system. So we have to increase or decrease the signal by using some signal conditioning system, and that could be an amplifier. Okay. That could be amplifier. Amplification could increase or decrease the signal accordingly. And lastly, the display system, which will show you the display as a digital output in the form of a LCD display, LED display, or there could be a pointer also as written over here, which will give you an analog value such that the pointer will move or rotate on the display system. Okay. So some example of the measurement system, this you can just see by yourself. Okay. So sensor to sense the value, the signal which you have got will be processed or conditioned, and then that signal will be made suitable for display and the value will be displayed through the display system. So this is simple measurement system and its elements. So what are the three main elements of a measurement system? A sensor, a signal conditioner, and a display. So if we compare it with the digital thermometer, then again digital thermometer will have a sensor, that is a thermocouple, an amplifier, that is a signal conditioning unit, and a display system, that could be LCD, LED, or a pointer moving on the your pointer moving on the scale. Okay. I hope this is understood till this point. It is understood or not?
Understood, sir.
Understood? Yes,
Yes, sir.
Rishabh, are you there?
Yes, sir.
Okay. Agam?
Yes, sir.
Okay, okay. So anyone can try and give some another example of measurement system if you are having any thing in mind. You can just discuss or you can give an example. As we have seen the example of a digital thermometer, can you recognize some other system which is a measurement system and utilizing a sensor and a display system as well as an conditional
Sir-
monitoring system?
Sir, digital speedometer.
Digital speedometer. Okay. So how will it work? What will be the sensor in that case?
Sir, sir, there are sir encoders sir हिंदी में बात कर सकता हूँ?
हाँ जी, बिल्कुल बिल्कुल.
हाँ जी सर, वो एक डिस्क होती है सर, डिस्क में स्लैट्स बने होते हैं सर, जो एक्सेल होता है उस पर डिस्क लगी होती है, और फिर सर एक हमारा एक लाइक लाइट भेजने वाला एक सिस्टम लाइक एलईडी लगी होती है, और दूसरी
जी.
साइड हमारा एक सेंसर लगा होता है जो लाइट डिटेक्ट करता है. तो सर
बिल्कुल.
जितनी जल्दी लाइट कटेगी उस हिसाब से वो फिर सर पता कर सकता है कि कितनी स्पीड है उसकी, एंगुलर रोटेशन कितनी है.
ऑप्टिकल, ये ऑप्टिकल सिस्टम है ना?
यस सर, ऑप्टिकल एनकोडर्स.
ऑप्टिकल एनकोडर आपका हो गया, एज ए सेंसर काम करेगा. उसके बाद फिर
यस
आपका
सर.
जो सिग्नल कंडीशनर होगा वो कौन सा होगा इसमें? सिग्नल
सर-
कंडीशनर क्या होगा इसमें? हाँ जी, कोई और ट्राई? बिल्कुल, आपने एग्जांपल बहुत अच्छा दिया है. Yes, anybody would like to try and give answer that what will be the signal conditioner in this case? You are getting some optical output from आपने optical input ली, उससे आपकी जो है generate electrical signal ही generate होंगे ना? तो electrical signal को दोबारा signal condition करने के लिए we will again use an amplifier. ठीक है? उसकी अब जो आपको डिस्प्ले है वो स्पीडोमीटर में डिजिटल हो या एनालॉग हो, again you will get the signal as per the EMF which is generated. तो आपका जो ऑप्टिकल सिग्नल है उसका भी आउटपुट जो रहेगी वो सेंस जो आपका क्या करेगा, लाइट को करेगा, एनकोड करेगा, और उसका आउटपुट इट विल गिव इन द फॉर्म ऑफ EMF ओनली. ठीक है? तो पहला सेंसर ही हमारा सिस्टम चेंज हुआ, आगे वाला सेम ही रहेगा. थैंक यू अगम, गुड. Now coming to the connected system. So connected system is basically a measurement system or a modeling system where number of modeling and measurement system, they are connected to each other. Okay. So that means here it is a big system where one input is the output of the other, or one output is the input to the other. And this system could be called a connected system. अगर जैसे मैंने आपको कहा है कि आपने कोई सिंपल सिस्टम बनाना है, तो सिंपल सिस्टम में आप जितने का सेंटर का यूनिट है उसको एज अ सिंगल यूनिट मान के चल सकते हो. दैट इज ऑल्सो पॉसिबल. बट इफ यू इलेबोरेट दैट सिस्टम such that there are number of subsystems in a given system or sub units in a given unit, there you will get a connected system where you will study it broadly and one output is the input to the other. Okay, so it will keep on going like that. So one output, then another unit is there for which the input is from the first output for the second, then again process after processing to the third, output from the second is the input to the third, and then you will get the final output. So interconnected system having number of input and output systems in between would be called a connected system. Okay? So a series of interconnected system where output for one system becomes input to the other and so on. Okay, in drawing a system in this way, it is necessary to recognize that lines drawn to connect the boxes indicate a flow of information in the direction indicated by an arrow. So here the information flow will only be in a single direction, which should flow in a given direction. Okay, that is important. So example is there, a CD deck, where now CD decks are now rarely used, but previously there used to be a CD-ROM, CD decks, where you have put some CD, and after the CD is read by some optical encoders or by some you can say optical systems, they actually generate some electrical signals which amplify the signal. Okay, after amplification, now you are getting some output signal. तो जब amplify हुआ तो उसके बाद what you are getting is you are getting some bigger EMF signals, but now you are not getting direct output from this electrical signal. You need to send it to the loudspeaker where this amplified electrical signal is further converted to sound. So that is why these two systems are connected to each other now. Okay, so this may be a measurement system. ये आपका एक measurement system बन गया, और ये आपका एक हो सकता है, this becomes a modeling system. So they are now connected. So one system is there, one simple system, two simple systems connected to each other, that gives a connected system. So this is one example. Similarly, you can have number of examples. So wherever you see that in the measurement system or in a modeling system, the output from the one is not the actual output which you require. You further require some system which will utilize that output to give another output, okay, which is of importance to the user. So that becomes a connected system. Okay. Just a second. Okay. Okay. So after the simple system which we have studied for the designing any mechatronic system, three systems we have studied. Okay. Now coming to the next part, that is the control system. So control system is basically an important part of any type of system. So this is not the further subcategory of mechatronic system. This is completely different topic. So control system is basically, you can say it is any control system can control anything which is an integral part of any of the mechatronic system. So it is a completely different category which we are discussing now. So that means any mechatronic system can be categorized in the form of you can say simple systems also. It can be categorized in the form of control systems also. Okay, so this is a completely different category which we are talking of. So control system. So control system, as the name suggests, it is used for controlling either some value. So as the name suggests, control system will control the value, some output value. Okay, so like in the previous system, you are getting some value in the outputs. So if you want to control that value for some desired values, that you can control through some control system. So control system is an integral part of any of the system which we have discussed so far. So it is a different category which we are talking of. Controls or control system का क्या काम है? Control system can control sequence of events, and control system can control the occurrence or non-occurrence of some event. So three main purpose of control systems. Control system either controls a variable value. Example is very good example is given over here. You see the air conditioning system, you see the heating system. If you have set the knob or set the digital system or the temperature to a given value. Now, after that value has reached, the system should turn off itself or it should turn on itself. That can also be possible. So this is a control system which is working. That means which is triggering some sequence of operations when some value is reached. Okay, to attain a given desired temperature in the room. तो एक्चुअल में हमें क्या करना है, हमें एक डिजायर्ड टेम्परेचर, ये टेम्परेचर की वैल्यू है जो उसको रीच करना है रूम के अंदर. सो यू आर कंट्रोलिंग द वैल्यू ऑफ द वेरिएबल. This is one. Control the sequence of events. Now, example is a washing machine. If you are selected a particular type of cycle in the washing machine, so number of sequence of operations will go on. Firstly, the water will fill, then the detergent will fill, then your water will be filled. Okay, so whatever, then your spinning will take place, washing will take place, then soaking. So all these sequence of operations should go on after one another. So you're controlling the sequence of operations. Then first of all, this operation should take place, then second operation, then third operation, and so on. So that can also be controlled through a control system. Thirdly, if you want to make an event occur or not occur in a given condition, that is also controlled by the control system. Example is a safety lock on the machine where it cannot be operated until a guard is in position. Okay, so a machine is working, suppose CNC machine is working, and we don't want any accident to occur, and we want then once the equipment or the tool or the workpiece has properly been loaded on the machine by the worker, then after shutting the door of the machine, the worker should come and be positioned at a given point. Only then the operation of machine should start. That type of system can also be controlled by a control system. Okay, so three type of functions of a control system: to control a variable value, to control the sequence of events, and to control whether an event should occur or not. Okay, so very important part in a control system is a feedback control. Feedback control system. Okay, so previously we have seen an example of a microprocessor or microcontroller which was placed between the sensor and the actuators. So what that feedback system is doing, or the microcontroller is doing, it is acting as a feedback system. That means whatever input has been given by the user, so whether that input is being fulfilled to attain the output or not, that needs to be checked through the feedback system. Okay, आजकल machines जो intelligent बन रही हैं अपने आप कैसे हो रही हैं? The more the feedback you are getting from the machine, it is becoming more intelligent. So what is happening basically? So example is, if you have given this much value by which the machine should move forward. Okay, तो पहले तो open loop system होता था without feedback system. That means our system, आपने एक उसको command दे दी, वो अपने हिसाब से it will go and reach the position, and you are very certain that my system is 99% accurate and it will acquire that position which I have calculated through my mathematical relations. Okay, मैंने mathematical relation से निकाल लिया कि मैं जब इसको इतना करंट दूंगा तो वो इतना मूवमेंट हो जाएगी उसकी. But what happens with the time, the system will wear out and you may not get that much of actual output which you have calculated, because that calculation is as per the ideal conditions. So your system will be having number of losses, frictional losses will be there, time losses will be there. Okay, so we don't know, if we are not considering those, then your actual movement will be very less as you have calculated. So we need to put a feedback system such that whatever input I am getting, either the output is also that much or not. If it is not, then it should again move a little further to compensate that loss, or it should retard back if it has moved further. So, ठीक है ना? तो वो चीज इंप्लीमेंट करने के लिए हमें एक फीडबैक सिस्टम चाहिए कि जिससे आपको उसको इंफॉर्मेशन आती रहे कमियों की, what are the what actually is going on. So feedback system is everywhere. I am teaching you, you are whatever is the course learning outcomes, if we are not achieving those, then the system in the university will ask you for the feedback that whether your teaching has properly occurred, have you acquired or have you attained the completed the desired syllabus or not. If not, there needs to be changes which need to be made for the upcoming semester or upcoming time period. Okay, so feedback system is always there कि जो हमें desired है क्या वो हमारी fulfill हो रही है, desire नहीं हो रही तो उस पे हमें changes करनी पड़ेंगी, then only we will make the system work more accurately, and that could only be implemented through a feedback control system. So example is a body temperature control system is there, like your temperature sensor which is controlling the temperature of the room. तो हमें required temperature है suppose 22 degree Celsius, ठीक है, 22 degree Celsius हमें desired temperature. अभी body का temperature suppose it is body के could be a human body, it could be a room. अभी room में temperature 30 degree है, तो जब तक वो 30 degree है उसको feedback आ रही है, feedback of the actual temperature from the environment. You are getting that feedback, and it is comparing the actual temperature which is attained and the required temperature. So it is not matching, still required is 22, still it is 30. So it will trigger the control system to give more you can say heat or coolness. Still more coolness is required, so the temperature should reach 22 degrees Celsius. Once it has reached 22 degree desired temperature, it will turn off the system, it will shut down the system. This could also be implemented to a heating system where one furnace is heating the room. There also, when till the point you haven't attained the temperature, it will keep on working at. This is done by comparing the actual temperature and the required temperature with each other through a feedback system. तो यहाँ पे feedback system क्या रहेंगे, जो body temperature, जो temperature sensors हैं, वो temperature को sense कर रहे हैं, and again they are comparing also. So comparators are also there. So sensing and comparing. So feedback system is basically comprising of sensing and then comparing it. And once it is compared, then it will decide for which type of signal is needs to be given. It should either it should be an on signal or it should be an off signal. Okay. So third example feedback system का है control system for hand position and movement. Okay. So this is another example. Once the hand has moved to the position where there is required, some input is required. Once it has reached that position, it will give a positive signal, or otherwise it will give a negative signal. Accordingly, अगर feedback है या feedback नहीं है, उसके हिसाब से आपके very important two type of control systems are there: open loop and closed loop. If you have a feedback system, that will be called a closed loop system. If you do not have any what you call feedback system, then it will be called a open loop control system. So what is the difference between open loop and closed loop control system? Only the feedback system, absence or presence. The feedback system absence makes the control system a open loop control system, and the feedback system presence make the control system a closed loop control system. So which type of system is better? In your opinion, which is a better system? Open loop or a closed loop?
Sir, closed loop.
The closed loop is better.
Closed loop is better, always better. But for those type of systems where such a precision in movement is not required, or such precision in temperature monitoring is not required, we can skip the feedback system, because obviously with the presence of feedback system, the overall system becomes a little expensive. Okay, तो अगर हमें इतनी ज्यादा प्रेसिजन नहीं चाहिए तो हम इसको स्किप कर सकते हैं to reduce the cost. But accuracy is obviously always better for a closed loop control system. Okay. So example of a heating of a room with or without the feedback system, how it is working. Now input is the decision to either switch on or off the heater, है ना? आपने अब हीट रूम में हीटिंग करनी है तो ह्यूमन ने डिसाइड करना है कि आइदर मुझे ठंड लग रही है तो मैंने हीटर ऑन करना है, अगर मुझे ठंड नहीं लग रही तो मैंने हीटर को ऑफ कर देना है. So the decision is to switch on or off. That is the input, and that is the controller. Here the controller is the human. And what is the actual control? Switch is the control. On off switch is the control, which is a hand activated process. Once you have switched on the heater, electrical power is the input to give some electric fire. So this is an example of electric fire. There we can directly use a relay also, or a resistance also, to heat the room, or some type of liquid oil also to heat the room. So electric fire will turn on once the power is given, and the output is the change in the temperature. So how much change is there, we don't know. We don't want our system to be automatically turned off. We are just turning it on, and it is continuously giving heat, and the temperature is rising. And once we have felt that now the sufficient temperature is reached, we will manually turn it off. So this becomes a open loop control system. Okay. Now here everything else is same. The controller is the person, hand activated switch is there, electric power is turning on the electric fire, and output is a temperature. Now here we have the benefit that we can attain a constant temperature. Once we have decided that we want, when we are heating, we want our temperature to be at 25 degrees Celsius only. Here the temperature will continuously keep on increasing. Here we can set it to constant temperature 25. Okay. For that, what needs to be done? An extra measuring device, that is a feedback system, needs to be installed. So whatever temperature is there, it will keep on measuring it, and this feedback will be given to a comparison unit. Comparison element will compare the feedback temperature and the input temperature, and if there is some deviation, then those will be that value will be given to the person which will operate the switch, or this could be automatically operated also. This switch could be automatically operated also. So this is the difference. That means the measuring temperature needs to be there. So feedback system के साथ एक comparison unit लगाना जरूरी हो जाता है, फिर तभी वो actual में implement होगा. तो अपने measurement की feedback system से उसको implement करने के लिए we need to add a comparison unit also. Only then the system will become foolproof. Okay. So After that, we will discuss the basic elements of closed loop control system and a little part of this analog to digital converters. And with that, this control unit part will be covered. Okay, we will not be going into further details of the system. Then we will be switching to the next chapter. So not much of the part would be covered, just some important aspects of control units or control systems with some examples so that you are able to understand it. Okay, so I think for today it's sufficient. If you have any doubt, you can ask any question. So any questions, any doubt?
No, sir.
No, sir.
Okay then. Okay, thank you very much. So we will end the lecture now.
Thank you, sir.
Okay, welcome.